Okay, kid. Wow. I don't even know where to start because there's so many things you need to know how to solve this. It's not even funny. So, you've done this with equations, so it's the same thing except that instead of an equal sign, it has an equality. So try to follow for a little bit, and then I'll start doing some of the problems that I have here that your mom sent me, and then hopefully it'll ring a bell or or something. All right. So things you need to know. Whew, I don't even know how to start this. Okay, so let's start with a simple equation. Okay, let's start with this. I don't know what they taught you in your school. Uh, I do this the old-fashioned way because I'm assuming that's probably how you learned it. So it's x plus 3 equals 7. Now I know this is an equal sign, okay? So let's just pretend I'm going to do a bunch of examples with an equal sign and then change it to an equality, which is either this, or that, okay? But the way to solve it is the same thing, except those symbols are in instead here. Okay, this is a simple equation. We want to have this at the end. X equals something. So we want to eliminate the 3 over here. Okay, so the basic standard algorithm or the procedure is get rid of the 3 in order to have. So let's just divide this into two sides, the left side and the right side. My left side has to look like that, just an X. In order just to look like an X, I have to get rid of the 3. In order to get rid of the 3, I have to eliminate the positive. It's a positive 3, and to eliminate something that's positive 3, you're going to put it together with a negative 3. In an equation, whatever you do to one side, you do to the other. Hopefully this is ringing a bell. If it's not, you're in trouble. I hate to say that, but you are. These two cancel out. Bring the x down. The equal sign comes back, and 7 minus 3 equals 4. So that's your answer. X equals 4. Now, let me show you why that is your answer. Okay. If you go back to your original equation, x plus 3 equals 7. Now you have the value for x, which is 4, right? You can substitute 4 plus 3 equals 7. Is that a true statement? Yes, because these two added together is 7, which equals a 7 on the other side. Okay? I'm going to do a different one. Y minus 5 equals 8. All right? So difference here that this is a subtraction sign. The previous problem was an addition sign. Okay, so again, our objective is to isolate the y, have y all alone by itself, looking like this. In order to accomplish that, we have to get rid of that 5. It's minus 5 we have to get rid of. So I tell my kids to do this: separate, make an invisible, imaginary line where on top of the equal sign, where it divides the equation into two sides, the left side and the right side. I have to get rid of the 5 because getting rid of the 8 doesn't help my cause here. It's the 5 that's next to the y, not the 8. It's on the other side of the world. It has nothing to do with anything. To eliminate the minus 5, you do the opposite of that, which is plus 5. If I do plus 5 on one side of my equation, on the left side, I'm going to do the plus sign on the other side. These two cancel each other out because they're opposites. Y comes down. There's nothing else. The equal sign comes down, and now you have 8 plus 5, which is 13. If you plug this into your original equation, you get, the original equation was y minus 5 equals 8. So subtracting, you get 13, because that's the value found, minus 5 equals 8. Is that a true statement? Yes, it is, because 13 minus 5 is 8, and 8 equals the other 8 on the other side. That's a subtraction equation, okay? Let's go for a multiplication equation. This, cutting corners here with you. So take 3a equals 12. Okay, that says 3 times a number that we don't know equals 12. How do we solve this? Again, our goal is the same, is to isolate or have our variable by itself. Okay, so it's a multiplication. It's multiplication that's happening between the 3 and the a. Who do I have to get rid of? The 3. I won't get rid of the 3 via addition or subtraction this time. I'm going to do it by the opposite operation of the multiplication here. The opposite of multiplication is division. So I'm going to take that and divide that by 3. Again, what's 3 divided by 3? I get 1. 1a, or simply just a. It's the same thing, remember? 1a or just a means the same thing. That's why that's why nothing. It's just 1a is just simply as a. Okay, and then on this side, because I divided this side by 3, I must divide this side by 3 as well. And 12 divided by 3 is 4. Go back to the original equation. You had 3 times a equals 12. See if that's true. Now that you know what the value of a is, plug it in. 3 times 4 equals 12, and you know that 3 times 4 is 12, so that equals the other side, which makes our equation true. Okay. Okay. So next, the other type of equation we can have something like this: m over 6 equals 4. This says a number divided by 6 equals 4. You and I both know that that number it's going to be 24. But how do we do this? Showing work. So again, our objective is to have your final line looking like this: m equals something. Now, this says division. This is dividing by 6. So, how do I make? I don't want to make this. Okay, best way to do this. Okay, is to now cross multiplication. That's not going to make any sense to you. Okay, this is dividing by 6, right? Dividing by 6. Here's what we're going to do. We're going to multiply by 6 and multiply this by 6. Okay, which is the reciprocal of 1/6. So see the denominator here, it's 6. We're going to multiply the denominator. Alright, hang on a second. We're going to multiply m over 6, which is what you originally have, by the denominator. The denominator is 6, so you're going to take that and multiply by 6. That's how I got the number 6. Whatever I do to one side, I must do to the other side. The 4 will also be multiplied by 6. So on this side, it's easy because 4 times 6 is 24. Here, this 6 and this 6 will cross out, giving you an m. Okay. And there's our answer, m equals 24. Let's see if that works out. M over 6 equals 4. Let's see if that's true. If I substitute and plug it in here, I get 24 over 6 equals 4. And 24 over 6 is indeed 4, which gives me 4. Okay. Alright, so that's really a short Reader's Digest version of equations. Now you have these greater than or equal or less than or equal, okay, that you have to worry about. Okay, so let me take a couple of problems that I saw in the sheet there. Okay, let me see. Not this one. Okay, so I'm going to take, forget what page 129, and I'm just going to do a couple here and there. And hopefully this will bring about from what you learned in school. 2x is greater than 4x minus 6. Yikes. Okay, alright, so our objective is the same. We want x, we want this. Hopefully you know how to add and subtract integers, kid. So let's see how we do this. Okay, so in this particular problem, I have variables on both sides. I have an x here and I have an x here. You have to somehow you have to transfer all the x's from one side to the other side. You can't have a variable on both sides. So when you were doing equations, you can't have, for example, x equals 5x. You can have x equals 5, which is okay, a variable on one side and a number on one side. That's okay, but you can't have a variable like this equaling something with a constant and a variable. So somehow we gotta get rid of the x on one side. Okay, so here we go. Step 1. Pick either the 2x or the 4x. You're gonna either get rid of the 2x or get rid of the 4x. My suggestion to you is always to take the one on the left side. Pick a side. Okay, does it really matter? No, but for our sakes and purposes here, we're gonna take the 2x, and that's the one we're gonna keep. So I'm gonna keep the 2x. I'm gonna get rid of the 4x. So here's what I do: 2x. Oops, no, that's not what I want to do. No, that's not what I want to do either. I want to do this. So I'm going to get rid of the 4x. How do I get rid of the 4x? I'm going to subtract. That's a positive 4x. So in order to eliminate, I'm going to subtract 4x. Remember, whatever I do to one side, and again, here is that imaginary line, okay, that separates the left side and the right side. If I subtract 4x from this side, I'm going to subtract 4x from that side. This is what you're going to end up having. So let's bring that inequality sign down. On this side, you have 2x minus 4x, and 2x minus 4x, if you write it like this, okay, 2x minus 4x is going to be negative 2x, okay. Copy the constant, the x stays the same, and just subtract positive 2 minus 4, which is negative 2. On this side, plus positive 4x and negative 4x will cancel each other out, and this negative 6 comes down. Okay, make sure you bring the 6 along with the sign right before it. Now, again, we want our answer to look like this. In order to look like this, I have to get rid of the negative 2. Remember, this is a multiply. These two are being multiplied. So the opposite of multiplication is division. So I'm going to divide this by negative 2. What happens when I divide negative 2 divided by negative 2? They cancel each other out. Okay? And I must divide the other side by negative 2. So negative divided by negative gives me a positive. 6 divided by 2 gives me a 3. You're not done with your answer because you're asked to graph this. Okay. Now, difference with a equation. An equation. Let me give you an example here. X plus 5 equals 3. X plus 5 equals 7. There's only one number in the world that makes that statement true, which is 2. 2 plus 5 equals 7. In this case, okay, x can be anything greater than 3. So going back to your original equation, you got 2x, 4x minus 6. You're looking for a number that you can replace, put it in here instead of that x. That will make this statement true. So that, what we just found out, says that it could be any number that is greater than 3. So let's pick a number greater than 3. Pick 4. Well, if you pick 4, you get 2 times 4 greater than 4. And we're going to take that x and substitute with another 4 minus 6. Let's see if that's true. 2 times 4 is 8. Greater than, what's this? 4 times 4 is 16. Minus 6. 8. And 16 minus 6 is 10. We did something wrong, or I did something wrong. Hang on a second. 10. It's 8 greater than. X has to be greater than 3. Hang on. Plus 3. X is greater than 3. 2. 8 is not greater than 10. Okay. Hang on. Shoot. Okay. What did I do wrong? 2x is greater than 4x minus 6. 2x minus 4x minus 4x. Alright, I'm going to press pause. Let me just figure this out. Okay, here was the problem. Okay, forgive me because I haven't done this for a while. What we forgot to do, and I guess the easier way is for me to just do the whole problem again. Okay, so the one mistake I made was here at the bottom, and I'll show you why. So it's going to be 2x equals